So this is my video on the law of sines, the second part, where we will talk about the SSA case with two triangles. You will recall that in class and in the previous video I showed you the case where we have one triangle, but now we are going to do the two triangle case as well as the no triangle case. So let's get started. So solve the triangle with a equals 6, b equals 8 and alpha equals 35. So as usual, we first start by trying to find the angle which is across a known side. So what's the known side here? So the known side, as well, a is 6, but then alpha is 35 is already known. B is 8, but beta is not known. So we should try to find beta using that ratio. So we have sine beta over b is equal to, and the other ratio is a known ratio, which is alpha to a, alpha and a. So sine alpha to a. Alright, so sine beta is equal to, what is b? B is equal to 8 is equal to sine alpha is 35 divided by a, which is 6. If you solve sine beta, you will get, if you carry the 8 over the other side, you get sine beta is equal to 8 sine 35 over 6, which is 0.76. Then we do the step of finding beta right away. The way beta gets is 49.9, and then as usual we know that there is another beta prime in the which has the same sign value in the second quadrant. So how do you find that beta prime? You subtract that original beta from 180 and then you get 180 minus 49.9, which is 130.1. So you got the two betas, right? So the two betas are 49.9 and 130.1. So now you do the normal check to see whether there is any space left for gamma for each of these beta. So first you take the beta, so you calculate 180 minus alpha plus beta b. So you calculate the difference between 180 and the two angles that we know now, alpha plus beta, and when you do that we get 180 minus alpha plus beta is 35 plus 49.9, and that comes to 95.1, which is positive. So that's positive, means there is space for a third angle gamma. That means we do have three angles. That means we have a triangle. This triangle is 1. So this particular combination, alpha beta and this gamma here, leads to a triangle. And now we try the other one. So that is, and we try 180 minus alpha plus beta prime. Okay, that's 180 minus alpha is still 35, but now instead of beta we put beta prime, which is what, 130.1, which we got from here. Okay, and when we calculate that, we actually get 14.9, which means for that particular beta prime also there is enough space to put in a gamma angle. So this is that gamma, and we can call it gamma prime, and that also gives a triangle. So we get a triangle from this combination as well as we get a triangle from this triangulation. That means we get two triangles. Okay, so both are positive, so that means two triangles. So now we need to actually find the missing side, which is C, because we know all the other data now, because we know the gamma that we calculated the gammas here, right? Okay, so this is basically your gamma. So let me write gamma there, right? And the other one that we found, sorry, this should be gamma prime. Okay, and the gamma, we can think of the gamma as this. So we actually have, we know the alphas, we know the betas and the gammas for the triangle, for both triangles, and we also know A and B. So what's the only unknown? The unknown is C. So we need to find C. Now let's start with triangle 1. So let's call this first triangle the triangle 1. Okay, so triangle 1, so we have alpha equals 35, A equals 6, beta B equals 8. Those are already given, and beta is what? Beta is 49.9, and gamma we found here to be 95.1. So we have that. Okay, and so if we want to find gamma, sorry, C, we need to use this ratio, sine gamma over C is equal to, then we can use one of the other ratios, but we use sine alpha over A because alpha is the original angle that was given to us. So if you plug in the values, sine 95.1 is gamma, divided by C is the unknown, is equal to sine alpha is 35 divided by A is 6. And then you cross multiply and then you get 6 sine 95.1 is equal to C sine 35. And if you solve for C, you get C is equal to 10.42. So in the first triangle, we do have the missing side C to be equal to C equals 10.42. And we do the same to triangle 2. Now the triangle 2 alpha and A and B are the same, but for triangle 2 gamma, beta is beta prime, right? Which is equal to, so what is beta prime? Beta prime is that second angle that we found here, which is equal to 130.1. And we can also, and gamma prime on the other hand will be the second gamma angle that we found right here, which is 49.9, which is gamma prime. And we put that for gamma prime 49.9 and we do the calculation. Again the same identical calculation, but now with the gamma prime and C prime, okay, and then we get the answer to be equal to C prime equals 2.69. Now this actual is a nice diagram which actually shows the two triangles, so you can see that you can actually you can see that you can have the notations are somewhat a little different, right? But you can think of the C as the gamma, so this is like gamma 2, the 14.9, right? And that gives one triangle, then that is this blue triangle right here, where beta is 130.1, and the other triangle is when gamma is 95.1, and that is the beta triangle, which is 49.9. So you get two triangles. One triangle is this and the other triangle is this, so you get two triangles. Now look at the other remaining case. So we consider the one triangle case, the two triangle case, and now let's look at the no solution or the no triangle case. This one you don't have to go too far, you will get the answer very quickly. So let's take an example. Solve the triangles. Solve A equals 1, B equals 2 and alpha equals 50. So as usual, we will try to find an angle which is not given but whose opposite side we know. So now gamma is not known, but gamma we do not know anything about C, so we can't even get started. But if you look at beta, the opposite side of beta is given, which is 2. So we can try to find beta. So then what happens? We get sine beta over B, but we know that B is equal to 2. So sine beta over 2 is equal to, and then sine alpha over A, right? So that's a known side because we know both alpha and A. We know the angle and side both. So sine 50 over 1, sine 50 over 1. Sine beta over 2 is equal to sine 50 over 1. Let's solve it for sine beta. So you solve it for sine beta, then you take the 2 across, you multiply both sides by 2, and then you get sine beta is equal to 2 sine beta over 1, which is equal to 1.53. Now that is pretty much the stop to the problem, because when you get something like sine beta is equal to 1.53, that's pretty much it, because you can't go beyond that, because sine has to always be between -1 and 1. So a sine value can never go above 1. So this is 1.53, and which is illegal because sine beta has to be always between -1 and 1. So this cannot happen, which means beta, right, cannot exit. So not a single triangle. So what's happened? So there is no triangle, not even one actually, and certainly not two. So not even a single triangle can exit. Now you can show this scenario in this little diagram actually. So we have the 50 degree and we have 2, right, which is B, a side of length 2 at 50 degrees, okay. So what happens is once you come down and then you have A, right, A is actually 1, not 11, A is 1. So you can see what's going on. At this configuration, A is too short, right, to create the triangle, right, okay, and that's what happens. So the three sides Do not this side, and this side does not create a single triangle. So that is a no triangle case. I hope you understood the question, and then please do one of the video problem, right? And I will see you in class on Thursday. We will do these two cases as well as do word problems in using the law of sines. Thank you.